Right, today we're going to talk about the much easier version of converting vertex form into standard form. Alright, here's a vertex form problem. Y equals x minus 1 squared minus 6. There's basically three steps to this, but they're a little bit more obvious, I think, than the vertex form, or converting to vertex form. So, right here, we have a FOIL problem. We have a perfect square binomial. So we're just going to FOIL this out. And you might learn pretty quick that these are always x squared, 2 times that, x, and then the perfect square of that, or the square of that. I don't know what the right term is. Then we have minus 6. So the second step, we don't have to do in this problem. If I had a coefficient, an a, I would have to distribute it through these three terms. Then I have to combine my constant terms. Y equals x squared minus 2x. In this case, I have minus 5.
Oh, this is so much easier.
This is much easier than converting to vertex form. The other nice thing about this is there really aren't any that are hard or impossible. So I could just make one up off the top of my head. X plus 3 squared minus 12. And you can easily convert that. Right? So you can convert every vertex form into standard form. That's why we call standard form, because every parabola can be written in that form. Unlike with the vertex form, like last night you saw, sometimes you'll start getting weird fractions and things like that as you try to complete the square. So this one, the key thing to remember here, a lot of people go, oh, here's a coefficient, I'm going to distribute that across these. It's a lot easier if you do that second. You could do it first, but you'd have to only distribute it to one of your terms. And then you would have like x plus 3 times negative 3 minus 9. It's just a lot more confusing. So do FOIL first. It's like going back to PEMDAS. Exponents before multiplication. So in this problem we have x plus 3 squared, which is x squared plus 6x plus 9. Oops, I forgot my negative 3. Minus 12. So here my second step is I'm going to distribute negative 3 to each of those terms. Negative 3x squared minus 18x minus 27 minus 12. This is not affected by this. And then I'm going to combine my constant terms. Y equals negative 3x squared minus 18x minus 30. 27 plus 12 is 30. Okay. Which step are you looking at?
I'm just confused with
Over here. Okay, let's do one where I write out the FOIL. So, y equals 2x minus 5 squared. I just use minus 1. Let's do minus 10. So what I'm doing for the FOILing is this. X minus 5 squared. So x minus 5 times x minus 5. And I'm just saying x times x is x squared. X times negative 5 is minus 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is plus 8. That's all still in parentheses. And we still have a minus 2. You guys should try to get comfortable with these perfect square binomials because it's something that you'll see a lot. And if you can recognize the pattern of 2 times your second term and then your second term squared. So this is 2 times 5, or sorry, this is 2 times negative 5, and this is negative 5 squared. Right? Recognizing that pattern will help you in more than just vertex form. Okay. So let's finish this one off. We have to distribute our 2. The 2x squared minus 20x plus 50 minus 10. And we can combine the 50 and the negative 10 to be 40. So this expands to this. 2x squared minus 20x. All right. Okay. Got it?
Yeah.
All right. Let's trying to decide if I should record this or not. Let's record this and let's just do. Let's just do some of these. X plus 7 squared. What is that if we FOILed it out? We have x squared, then we have 14x, because that's 2 times this, and then we have 49. Yeah? Let's do another one. X plus 3 squared. First term, everyone say it.
X
X squared. Second term. 6x. Last term. Very good. X minus 12 squared. First term. Second term.
Minus 24. Plus 144.
Negative
144.
Okay, this is what I heard. This is what I heard. Raise your hand if you see what's missing. This is what I heard.
The X after
I need an X there, right? Alright, let's do some more. X minus 2 squared. First term.
X squared.
Second term.
Minus 4x.
Last term.
2, 4.
Okay. X plus 3 squared. First term.
X squared. Plus 6x plus 9.
These look really similar.
Yeah.
That's
what they say. What's up?
Okay.
No, they're not. They're not.
X plus 10 squared.
X
First term.
squared plus 20x plus